Assalamualaikum warahmatullahi wabarakatuh and good morning to our respecting managing directors, member of the board, senior corporate executive, department head, and all engineer operational personnel presented today. My name is Muhammad Atif Haji bin Muhammad Reddy. My metric number is 23139170780, presenting under course code UR65230008. Today, I am speaking to you as the safety officer for Noltec Com Sundaram Berhad, specializing as a telecommunication infrastructure specialist. The core objective of this session is our statutory safety briefing and OSH system implementation. Our organization stands at a critical operation crossroad. As telecom infrastructure specialist, our daily operation carry inherent risk ranging from work at height of 30-meter monopole to electrical tie in structure in structure. This presentation serves as our structural blueprint to accelerate safety compliance and achieve total readiness for our upcoming Department of Occupational Safety and Health, or known as DOSH, compliance audit, which is scheduled exactly 4 weeks from today. Over the 20 minutes, I will detail how we map our legal obligation directly into Regis mathematical risk module to protect our workforce and insulate our organization from severe liabilities. So, let us establish from the legal foundation of my appointment. As shown on the slide, my role is legal appointment mandated by OSHA 1994, Section 29. This means my presence and enforcement power are legally required under Malaysian law for organization with our risk and operational profile. My mandate is divided into three functional areas. First, my statutory duties require me to systematically inspect our workplace, thoroughly investigation incident or near mistake, and continuously maintain our organization safety metrics. For the second thing, the law grants me the specific statutory power. This power gives me the full authority to step into any activity site and order an immediate stop to unsafe work, demanding immediate compliance from personnel and report findings directly to the managing director without an administrative delay. And the third thing is I serve in advisory role to this board, guiding the C-suite on the technical hazard control and systemic OSH improvement. This structure ensures that safety is backed by federal law and integrate into our daily reporting line. So we go for the next thing. The next thing is the threat of the OSH justification. So why we must approach safety without absolute seriousness? With absolute seriousness. We justify our OSH system through the three distinct pillars: legal obligation, moral and ethical duty, and finally the financial sense. Under legal obligation, we are bound to maintain the strict compliance with OSHA 1994 Act in the column Act 514 and the Factories and Machinery Act in 1967 in the column Act 139. Following the statutory requirement, open the company and its director to criminal prosecution. So for the next thing is the moral and ethical duty. Our mission is clear. We must respect human life, prevent irreversible pain, disabilities, and the tragic loss of life. No corporate target or rollout deadline is worth the physical well-being of our workers. Finally, looking at the financial sense, a robust safety system allow us to avoid heavy statutory fine, crippling insurance spike, and project production halt. As I draw the board attention to our financial reality check at the bottom of the slide, there's a hidden indirect cost of an accident, such as a legal fee, project delays, and reputation damage, and 4 of the 10 times higher than the direct costs covered by the standard insurance. Safety is a direct investment in our protecting our operational bottom line. So we go for the next thing is that general duties of the employers. So as we look directly at the legal responsibility of our executive leadership under OSH 1994, Section 15, the law places non-delegible duties on employees to protect their workforce, broken down into 4 structural pillars on our slide. First thing first is the management provides safety system by maintaining plan and system of the work that are fundamentally without risk to health. This means our machinery, climbing gears, and operational workflow must be certified safety. And second thing is the management must ensure safe handling. We are legally required to secure safe arrangement for the use, handling, storage, and transport of heavy engineering equipment and material. Third, you must provide information and training. We must equip all field personnel with necessary OSH technical knowledge, certification, and back it up with active competent site supervision. Fourth, management must maintain a safety environment work, ensuring all the activity workspace have a secure access, safe egress, and adequate welfare facilities, such as clean water and first aid access responsibility. And for the responsibility, start at the top. If safety resources are withheld, the legal liability rests squarely on the management. So for the general duties of employer, we must follow this section 15. So we go for the next thing. So for the next slide is about general duties of employees. This do this slide is focusing on to create a safety workplace and legal responsibility must be balanced on the ground. OSHA 1994 Section 24 outlines the statutory duty of our employees. Compliance is not optional for field crew. It is a federal requirement. This framework operational tool for interlocking gears. First and foremost is the reasonable care. Every worker must take personal responsibilities to protect themselves and their colleagues who may be affected by the active choice or omission on site. And second thing is the corporation workers are legally required to fully cooperate with management and with me, the safety officer, on all OSH statutory mandates that worker equipped, must be protect themselves and colleagues affected by their action. And for the third thing is that is PPE compliance. Every technician must properly wear and use all personal protective equipment provided by the company, such as a specialized harness, high visibility vest, and hard hat. Fourth is the adherence to instruction. Worker must comply strict with our established safety rules and standard operating procedure at all the time. Section 24 ensure that workers who take shortcut or ignore the safety rules can be held personally and legally liable under the law. So we go for the next slide. The Escalated Reality by OSHA Amendment Act 2022. For this, we must urgently address the changing legal landscape in Malaysia brought by the full enforcement of the Occupational Safety and Health Amendment Act 2022. This amendment increased our corporate liabilities dramatically. As a visual on the slide chart, this maximum financially penalties for employers non-compliance has skyrocketed from the old limit of the 50,000 ringgit Malaysia to a massive 500 500 500,000 ringgit Malaysia. As a single civil compliance failure can now cost $500,000 in direct line. In addition to these financial penalties, the amendment enforced imprisonment of the 5 years for corporate directors and managers for severe or escape offence. It also introduced mandatory risk management, making proactive system hazard control of the standalone legal requirement across all the operation. And finally, the law features an extended scope, meaning this regulation apply universally to all workplace across all Malaysian. Removing all industry assumption, cutting corner is no longer is a regulatory risk. It is a critical threat to our corporate viability and executive freedom. So we go for the next slide. Engineering ethics, DEM code of conduct of principle one. As a technical professional, our engineering action are guided by professional ethics. Under the Board of Engineer Malaysia or BEM Code of Conduct Principle 1, our professional mandate is clearly defined a registered engineer or engineering technologist in his responsibility to his employer, client or the profession shall have full regard to the public interest. So let us break down exactly how this principle translate to our technical operation at Noltelcom. Sendirian Berhad, it is established paramount duty. The safety, health and welfare to the public and our workers must always come first. Ahead any other metrics, it dictates a strict ethical obligation, no commercial motive or project timeline or rollout deadline can ever supersede human life. Finally, it demands a sustainable protection and requiring our engineering technologies to ensure all physical environment and telecom installation are structurally and socially secure. Safety is not administrative add-on, it is core ethical definition of our engineering profession. We go for the next thing, the systematic approach by MS 1722 2011 OSHSMS. So to ensure our safety compliance is manageable and sustainable, the Nortelcom Sendirian Berhad adopt the Malaysian Standard MS 1722 2011 frameworks. This standard established a formal occupational safety and health management system operating as a structural wheel with a five core element. It's begin at core one policy, which represent our written committee's commitment to worker safety and absolute legal compliance, signed by executive leadership. This fit into the core two, organizing, which defines clear roles, responsibility and accountability while activating our safety committees. Next, next is the core three, planning implementation, the tactical phase where we execute proactive HIRAC or HIRARC and set measurably safety objective. This move to the fourth core, that is the evaluation core, where we conduct a site audit, monitor field performance, and investigating incidents to gather data. This lead to core 5 action for improvement, which mandate corrective and preventive action to evolve the system. This structure will ensure safety is built directly into our ongoing operation. So we will go for the next thing, that is the engine of safety, PDCA cycle integration. To make our MS1722 management system dynamic, we integrate into dimming continuous plan, do check, act, or cycle, or known as PDCA. These cycles serve our active engine for safety. In the quadrant, we handle policy formulation, planning, objective setting, and core hierarchy development. Moving to the do quadrant, we operationalize those plans through organizing and implementation, which includes running training and executing our standard operating procedure on site. We then trans we then transition to check the quadrant, which focusing on evaluation through physical audit and tracking both leading and lagging indicators. And finally, for this the engine of safety, we reach the act quadrant driven by action for improvement through formal management reviews and correlative action to fix any discovered weakness. As highlighted by the arrow at the bottom, this integration results in a self-sustaining cycle of proactive mathematical risk reduction, preventing our safety program from becoming stagnant. And we go for the next thing, that is the GOSH High-Rec Guideline 2008, the core definition to execute active risk management. We must align our technical language with the official GOSH High-Rec Guideline 2008. We must accurately distinguish between our four fundamental terms. First, a hazard is defined by as any condition with the potential to cause injuries, disease, or damage. It is a talent source of harm. Second, risk is the mathematical probability that harm actual occurs, calculating by the using formula risk equals to likelihood times by the severities. Third, the danger. This describes the relative exposure to unmitigated hazard, marking the point where workers are actively vulnerable to injury. Fourth, safety is defined as the relative freedom from hazard via active exposure management. Our statutory mandate requires us to recognize that proactive assessment is legally required before works begin. We do not wait for an accident to occur or to happen to see where is the danger lie. We manage hazard early to maintain the safety. So we go for the next thing in this slide. On the other slide, the sixth step of the highway operational flow chart. So in our tactical execution, follow a strict step-by-step sequence mandated by the OSH. We realize here as a clear six-step operational flow chart. Every project manager and site supervisor must execute this process in sequence. This process begins with step 1. Classify work activities where we map out and define all our routine and non-routine tasks. Next is the step 2. Identify hazard where our team spot physical, electrical, or and ergonomic threats on site. We then move the step 3, the risk assessment. Uh, this highlight in orange as our analytic core. where we calculate the likelihood multiplied by the severity for single hazard. Once score, we transition by to the step 4, the risk control implementation. This apply target mitigation to systematically lower high score. In step 5, we view we monitor control activeness regularly to ensure no new hazards are introduced. And finally, the step 6, document, where we maintain our official record for DOSH audit. This system, this system flowchart is what guarantees our operational compliance. So we go for the next thing. That is the mechanic of the 5 times 5 risk matrix. Let us look closer at the mathematical behind the step 3 by the analyzing of our 5 times 5 risk matrix. This matrix removes guesswork from risk calculation, assigning a clear score based on likelihood scale from 1 to 5 and severity scale from 1 to 5. The intersection of this variable gives us a clear score that places the risk into one of the three operational zones. The low risk zone, scoring 1 to 4 and highlighted in green, represent acceptable risk that can be managed with routine procedure. The medium risk zone, scoring to 5 to 12 and highlight in yellow, represent tolerable risk that requires structure control and plan mitigation. The high risk zone, scoring from 15 to 35 and highlighted in red, represented unacceptable risk. This metric mechanic dictate that any task scoring in the red zone, immediate action is required and work must stop. No personnel may proceed until engineer and administrative control have actively reduced that numerical score for out of danger zone. So we go. Okay, for the next part is the hierarchy master form. We will now transition directly into our operational master data, examining the core execution layer of our risk management framework. What you see on the screen is the first segment of our hierarchy master form, focusing on explicitly hazard 1 to 3, which isolate the chemical and electrical threat embedded within our target workspace, the electronic engineering lab and PCB station. Let us look closely at the hazard source 1. Manual soldering. Calculate at aggregate volume of 60 hours per day across our engineering cohort. The primary threat here is the flux fume inhalation. In our baseline assessment, where there are absolute no existing control in place, we scoring the likelihood of inhalation of the maximum of 3, meaning the exposure is highly frequent, combined with a consequences score of 2. This yield an initial pre-control risk score of 6, branding this activity as high risk operation. To mitigate this according to the mandatory hierarchy of control, we do not default this we do not default to standard dust mask. Instead, we implement a definitive engineering control. The installation of permanent local exhaust ventilation or LEV or put directly at the soldering station to capture and extract toxic chemical fumes at the source. By applying this engineering barrier, we, we mathematically force the residual likelihood down from 3 to 1, resulting a safe residual score of 2, bringing the task into the green low risk tier. Let us move to the hazard source number 2, PCB etching, where personnel handle ferric chloride risking chemical splash that can cause severe eye and skin burn. Our current baseline audit shows existing controls are limited exclusively to standard glove. This basic this basic barrier keeps our pre-control scores at a likelihood of a 2 and consequences of 2, calculating in a pre-control score of 4, which sit in the yellow medium risk band. Optimize our defense, we do not just buy better glove. We look higher up at the hierarchy. We implement substitution, replacing ferric chloride with a significant less toxic chemical enhanced agent. To account for residual splash risk during manual pouring, we pair this substitution with a mandatory PPE control, full coverage face shield. This dual layer mitigation drops the residual likelihood to 1, driving our final residual score down to a solid 2 or low risk. Finally, let us visit hazard source 3, circuit diagnostic, where our student and technician face the severe I'm sorry, where our technician face the severe threat high voltage shock from completely exposed terminal connection. Historically, our only baseline defense consists of passive warning sign pasted on the test bench. As your safety officer, I must emphasize that a warning sign does absolutely nothing to physically stop a human hand from contacting a live terminal. This weak baseline leaves us at a likelihood of 2 and a critical consequences of 3, resulting in pre-control score of 6, placing it directly back into the dangerous high-risk zone. To control this, we deploy a robust double-layer engineering control. We construct an automated testing enclosure that physically isolated the user, and we wire that enclosure with a residual current device or RCD power circuit off mechanism that instantly kills the live current if a breach is detected. This heavy engineering invention intervention drops our residual likelihood to 1. However, because live high voltage electricity fundamentally retains its dangerous property, the consequences score remained at 3, giving us a final residual score of 3, placing in the medium category. This means the risk is now tolerable and controlled to the absolute limit of technical practicality. So for the next, we move forward to the second tier of our master register, displayed on the slide 10, which catalog hazard 4 to 6. This section shifts our analytical focus towards the physical and ergonomic strain that quietly degraded the long-term health and short-term safety of our lab personnel. Look at the line item number 4, manual soldering, specifically focusing on the physical risks of the localized burn resulting from the accidental contact with a hot soldering iron tip. Our audit our audit confirmed that a safe tool rest is actively provided at every single workbench station. Because this base curve control is already functioning well, our baseline pre-control parameters cause a likelihood of 2 and a minor consequences of 1, yielding an initial score of 2 or low risk. Under the DOSH guideline, when a risk is called when the risk is already mathematically low, we do not over-engineer the solution. Our recommend control here is simply to monitor the station, meaning no additional structural modification are required. Provide provide site supervisor enforce tool rest discipline. This keep our active residual score at completely acceptable one, remaining firmly in the green low risk tier. Line item number 5, isolate PCB assembly, an activity that forced our engineer and technician into prolonged static posture, directly causing severe directly causing severe strain over a 3 hours lab session. Currently, our lab relies on basic rigid standard lab tool. Because this tool lack lumbar support and adjustability, the ergonomic likelihood of strain is high, scoring a 3 within consequences of 1, totaling a pre-control score of 3, which represent a clear medium risk hazard to structurally fix this ergonomic vulnerability. We apply to pro, we apply to a two-pronged control strategy. First, we roll out an administrative control, a strict mandatory 45-minute job rotation schedule to ensure no individual remains static for too long. Second, we back this up with engineering control, completely replacing the old furniture with adjustable ergonomic seating to actively support correct spinal alignment. This dual intervention successfully drops both our likelihood and consequences to the baseline floor of 1, locking in optimization residual score of 1, low risk. Now, direct your attention to the line 6, PCB drilling, where our personnel utilize high-speed bits to current pathway, generating fine fiberglass dust that poses a severe inhalation hazard. Our current baseline relies on very weak defense, providing a basic dust mask, which is which is a low PPE control because masks frequently leak and worn out. The pre-control likelihood sits at a high 3, paired with consequences of 2, creating a highlight dangerous pre-control score of 6, placing this task in the high risk category. We must reject relying on the PPA as our primary barrier. Instead, we implement a permanent engineering control. We isolate the mechanical process within enclosed drilling station, integrate with the localized vacuum extraction to pull fiberglass microparticles completely out of the breathing zone. This structural change reduces our residual parameter to a likelihood of 1 and the consequences of 2, successfully delivering a safe residual score of 2 for low risk. So we move on to the third IRAC master form. Uh, the Now we arrive at the final segment of our active register on this slide, detailing hazard 7 and 8, which focus heavily on housekeeping and environmental variables surrounding our engineers' workspace. Let us evaluate line item number 7, lab layout, where we have identified major housekeeping hazard, trailing power cables running across pedestrian pathway, causing immediate trip and fall hazard. Our current temporary existing control consists of cable being taped down to the floor. As engineering professional, we know that heavy foot traffic quickly degrades adhesive tape, causing it to peel and create an even worse trap. Thus, unmitigated hazards cause likelihood of 3 and the consequences of 2, establishing a high dangerous pre-control score of 6, placing it in the high risk zone. To permanently eliminate this physical threat, we implement a solid engineering control. We completely strip the cable off the floor pathway and reroute all the power lines overhead via dedicated ceiling trays. By the physical removing and the obstacle from the walking plane, our residual likelihood drops to down to an absolute one, resulting in safe complaint residual score of 2 or low risk. And finally, let us look at the item number 8, adjunction workshop machinery. This highlights the environment hazard where our lab personnel are exposed to the ambient noise level exceeding as decibel, radiate, radiating directly from the heavy CNC routers operating next door. Our baseline audit shows absolutely no existing control. Managing the noise boundary, this exposure score likelihood of 2 and consequences of 2, registering a pre-control score of 4, which land in the yellow medium risk tier rather than taking the easy way out and handling out earplug, which blocks worker communication and sit in at the bottom of our control filter. We go straight for the high-level engineering control. We construct a permanent acoustic isolation enclosure around the noisy CNC machine in the adjacent workshop. This dampens the acoustic transmission at the source, dropping out residual parameter to likelihood of 1 and the consequences of 2, resulting is resulting in a verified residual score of 2 or low risk. I draw the entire board and management team the attention to the critical technical banner at the base of this final slide. Look at look at the mathematical translation across all the three slides. Notice how our applied engineer substitution and administrative control systematically and mathematically force our initial high risk scores down to bring the schedule score. This is not subjective opinion. This is a data-driven, objective proof of workplace safety that satisfies the strict criteria of our upcoming DOSH audit. This complete 8 hazard matrix provide our workspace with a total legal defensible risk protection. Is the hierarchy control of pyramid. When lowering elevate risk score, we are legally required to choose control based on hierarchy of control pyramid. This invert model ranks mitigation from the most effective and the top of the least effective last resort at the bottom. Our first priority must be elimination, which means physically removing the hazard entirely from workplace. If elimination is not possible, we look at number 2, the substitution, replacing the hazard with a safer alternative. And third are the engineering control, such as guard or lockout. Take out system which structurally isolate people from the hazard. Fourth are the administrative control, which focus on changing the way people work through safety training, warning signs, and adjust work shift. At the bottom pyramid sits number 5, personal protective equipment or PPE. PPE is our least effective option and must be used as a final line of defense because because it does not remove the hazard. It only places a barrier over the workers. We must design our system focusing on the top of the pyramid. So we go for the next slide. There is the telecom infrastructure work integration. Let us look at our actual work area integration for standard telecom infrastructure tasks. Antenna installation and cable on the 30-meter monopole. We have mapped our top 3 real-world hazard using our risk matrix and control. Hazard 1 is working with height, carrying initial high risk of the catastrophic fall, falling a height 20, scoring a high 20. We must mitigate this by implementing an engineering and PPE control, installing certified anchor points enforcing a 100 ties of rules and providing full body harness. Hazard 2 is high voltage exposure. The skin fatal electrocution, which score high 15, which score a high 15. We control this through an engineering mitigation, enforcing strict lockups or slash tag out or LOTO isolation protocols before the works begin. Hazard 3 is the heavy equipment hoisting, risking a structural crush or drop injuries, which score a medium 12. We manage this with administrative control, establishing clear exclusive zone on the ground and utilizing certified riggers only. This target layout show how technical engineering risks are systematically reduced on the site. And finally, for the final slide is the summary and the call to action. GOSH audits re- re- readiness. And as we conclude the briefing, let us look at our operational timeline. The DOSH compliance audit takes place exactly 4 weeks from today. To ensure a successful pass and protect our workforce, we must execute this immediate action. Management must take the three immediate action by Friday, one sign and distribute, and the update corporate OSH policy. Two, uh, second, the authorize the budget required for our critical engineering control. And the third thing is the convenience of the official safety commit, committee. At the same time, our worker must take three immediate action. One is the inspect and wear all provided PPE properly on every site. Two, report all the near miss immediately through our digital log without fear of reprisal. And third, follow all the safe operation procedure without taking shortcuts. Our next step are clear. Our PDCA loops is initiate and our countdown has begun. Let us execute this plan together to lock in our compliance and maintain the safety secure workplace. Thank you.